So we discussed last meeting, uh, an introduction to digital communication multiplexing and particularly T1 carrier systems, right? We ended here. So T1 digital carrier systems. So essentially, it's just how much? 24, no? 24 PCM channels nga gi-feed sa isa ka 24 input multiplexer. But again, as stated sa bottom part sa slide, simply the 24 voice channel TDM does not itself constitute a T1 carrier system. At this point, the output of the multiplexer is simply a multiplexed first level digital signal. The system does not become a T1 carrier until it is line encoded. Line encoded and placed in a special condition cables called T1 lines. So T1 lines are a special type of specially manufactured cables for this application. So this afternoon, we're going to talk about line encoding. Line encoding methods. But before that, no, review sa tagamay sa mga some concepts that we touched last meeting. So let's try to answer these four sample problems. So example number 1, a PCM TDM system multiplexes 24 voice band channels. Each sample is encoded into 7 bits, and a framing bit is added to each frame. Sampling rate is 8,000 samples per second. BPRZ AMI encoding is the line format. So wala pa ni. Technically, dili ni magamit nga detail. But these are the type of line encoding techniques na itong ma-mention later. So let's solve for the line speed in bits per second and minimum Nyquist bandwidth. Actually, that naman no? Line speed meaning the rate at after naman ma-add ang kuan framing width. So here, no. Kung sa kuan pa sa kaninga system, this specific system T1 digital carrier system, it's 1.544 Mbps. 1.544 Mbps. So how much for this specific one? So problem number 1. It's just 9,000 times 24. Pila man na siya. $24 channel no. So yeah, 9 times 24 is 216. So maning unit ani. 9,000 samples per second. 24 channels. 7 bits per day. 7 bits. Wait, sorry. So 9,000, later pa rin na iko ng 9,000. 24 times 7. Okay, una. So 24 channels and 7 bits ang sample. So 24 times 7 is 168 plus 1, and a framing bit is added to each frame. So 169. 169 bits. Tanan. So 169 times 9,000. I think wala na ang final answer. 169 times 9K. $1.521 Mbps. That's the answer for the line speed. May check na ko sa 1.521. Yeah, correct. Mbps. So the framing bit is only added after ma-multiply na ang total bits per frame. So So 24 channels man and 7 bits per sample. 7 bits per sample sakto. So 24 times 7, that's 168 total number of bits per frame plus 1 for each frame. Kaya isa naman ka framing bit ang gina-add per frame. This one. Isa naman na siya ka bit. So 168 plus 1, that's 169. And multiply na to og 9,000 na sampling rate to have 1.5 to 1 Mbps. So for the minimum Nyquist bandwidth, i-divide naman na siya into 2. 1.5 to 1 Mbps divided by 2. Wait lang.
Ayan si Sir, wait lang.
So bandwidth is 760.5 kilohertz. Okay. So could you replicate that for question number 2? A PCM-TDM system multiplexes 32 voice band channels, each with a bandwidth of 0 kilohertz to 4 kilohertz. Sampling rate times 2 lang, no, sa bandwidth. So sampling rate is if voice channel man din, most definitely, okay, 4 kilohertz. So times 2. 4 kilohertz times 2 is 8,000 samples per second. So 4K line speed, the same sa itong gi-perform earlier. Multiply lang na ito ang 32 times 8. Each sound is encoded with an 8-bit PCM code. So 32 times 8 plus 1. 257 bits. Two five seven times 8,000. 257. Yeah, 257. Plus 1 naman yan, no? Again, 32 times 8 plus 1, 257 times 8K. 2.056 Mbps. See, divide lang na siya into 2. Bandwidth is 1.028 megahertz. Sa kanina questions from Dile, like butang lang na siya diya for formality. For the framing bit, Neil. Wala magibutang pod, no? Pero, kung ano na siya, understandable mo na siya nga na-framing bit. Same man nga system. PCM, TDM system, multiplexes 24, each with bandwidth. Dili man dependent ang na-frame or wala na i-add sa line encoding, which is in this case UPNRZ. Pero understandable man naman yung framing bit, no? I-add man gid na siya. So that's why nag-add ko buwan. Even though wala gibutang sa word problem or sa given, nagid na siya framing bit. So that's why mag-add tag 1. So for question 7 and 8, I think the same naman gyapon og concept, no? So pwede lang sige na inyo i-practice on your own so that we could now proceed to our main topic for this afternoon. So digital line encoding. Digital line encoding involves converting standard logic levels, whether TTL or CMOS, meaning ang most definitely ang mag-handle sa mga signals na may i-feed sa system is or are these kinds of technologies, okay, TTL, CMOS, and the like, to form a more suitable telephone line transmission. Essentially, 6 primary factors must be considered when selecting a line encoding format. So, kaning mga 6 factors, each of which atong isa-isahon, no? Transmission voltage, duty cycle, bandwidth, clock, error detection, and ease of detection and decoding. So I think it's better that if we'll compare each types of digital line encoding, and at lang sigurong ato makover ang kaninga considerations for each digital line encoding technique. So here are 5 most common, no? If mo search ta sa internet or sa other sources, they might produce many other methods. Pero again, kanyang pinaka most common, UPNRZ, BPNRZ, UPRZ, BPRZ, BPRZ-AMI. Kaning nasa right na table. No? So what does each letter mean? What does U and what does B and R mean? So in terms of the transmission voltage and DC component, this defines, this defines whether a line encoding utilizes unipolar or bipolar. Okay? Unipolar or bipolar. So what's the difference between the two? When we say unipolar, unipolar transmission of binary data involves the transmission of only a single non-zero voltage level. So, for example, either logic 1 or 0 lang maginatong ang atong possible outputs. So, example, logic 1 would use positive 5 volts, whereas logic 0 would use 0 volts. And so only a singular non-zero voltage level. So kung i-compare natin siya sa bipolar, kung sa bipolar pa ni, one example for a logic 1 sa bipolar is, pwede ka na, no? Positive 5. But for the logic 0, negative 5. So, reverse signs, but same voltage level, of course. In bipolar transmission, two non-zero voltages are involved. A positive voltage for logic 1 and an equal magnitude negative voltage for logic 0. So over a digital transmission line, it's more efficient to encode binary data with voltage that are equal in magnitude but opposite in polarity and symmetrically balanced because mag-cancel out silang duha, no? Ang if natulugar tayo 110 nga data na transmit. So, ang voltage level for 1 is positive 5, ang 0 is negative 5. So, mag-cancel out sila sa each other when it comes to power, no? Power consumption. So, mas efficient ang bipolar. So, for each of these, natay unipolar NRZ, may bipolar NRZ. Napo unipolar RZ ug bipolar RZ. Okay? So, well, upat gyud ka klase nga kuan atong come up, no, na combinations. So if there are two types of line voltages based on line encoding based on transmission voltage, there are also two types of line encoding with respect to duty cycle. No? So duty cycle defines if a line encoding technique is RZ or NRZ. So RZ means return to zero. And RZ means none. Return to zero. Okay. So what does this mean? If binary pulse is maintained for the entire time bit, this is called non-return to zero. But if the active time of the binary pulse is less than 100% of the time, more or less, or more often than not 50% good, this is called return to zero. So this is due to duty cycle, right? So, asa ginato na ginako ng duty cycle, the active portion, no? Di ba? The active portion sa period. So, if this is the period of our bit, kana siya. The active portion, no? Kung gano'n siya high, that's the duty cycle. So, when we say return to zero, once it goes high, after 50% of its period, mo return siya to zero. Di rin lang siguro. I think di naman yung 50%. Mo return to zero. And that. So, the same gyapon kung negative. No? If this is the period of a negative na bit, once mag-low siya, it will always return to zero. Unlike sa non-return to zero nga, it it will maintain that voltage level until mahuman ang period. So example, sa kuha na lang siguro sa table, diba? So each of these are the type of line encoding techniques. So ang first one is ang unipolar non-return to zero. Ang ikaduha is bipolar non-return to zero. Ikatulo, unipolar return to zero. Kaupat, bipolar return to zero. Diba? If we are given this arbitrary example of a stream of bits, 1, 1, 0, 0, 1, 0, 1, 0. So, arbitrary na siya. That's just for the sake of an example. Notice sa unipolar, if logic 1, positive V volts, or let's say 5 volts siya. So, positive 5. Pag logic 0, 0. Okay? So, that's the difference between unipolar and bipolar. Kung bipolar, kung logic 1, positive volts. Kung logic 0, negative volts. Okay? So, before I proceed, understand ang difference between bipolar and unipolar? Okay? So, basta kay ang ato lang itimanan, basta unipolar, iyang logic 0 kay 0 volts. Yan na lang. Basta bipolar, iyang logic 1 ug logic 0 kay plus minus volts. So, logic 0 sa unipolar kay 0 volts. Whereas ang logic 0 sa bipolar is negative volts. Yan lang, no? So now how do we differentiate non-return to zero and return to zero? So non-return to zero, notice sa logic 1, na-maintain niya ang positive volts until nahuman ang period. Mahuman ang period, diba? Dila o TB. Mahuman ang period sa isa ka bit, no? From start to finish, sa bit is high gid siya perme, or nala siya sa positive volts. So let's compare UPRZ and UPNRZ. Diba? So, basta unipolar gani, di ba, again, ang iyang logic 0 is 0. Ang logic 1 is positive volts. So, kung gusto siya mo transmit og logic 1, kasi ito itong given example, 1, 1, 0, 0. So, 1, 1, 0, 0. So, kung gusto siya mag-transmit og 1, mag-high siya, no? Positive volts. But, after 50% of the period, mo return siya to 0. Then, 0 volts. Tungkol kay 1 ang next na data, high na po siya. But after 50%, mo return na po siya to 0. So, kung 0, of course, 0, either 0, kani 1 man delay. So, mag-high siya, then after 50%, mo return na po siya to 0. So, that's UPRZ. Kung BPRZ, return to 0. The same gapon, no? High siya for 50% of the time, then will return to 0. High na po 50% of the time, return na po to 0. Dala, logic 0. Low siya, no? Negative volts. Return gapon to 0. Low siya, because 0 man siya dire. 1, 1, 0, 0. and mo return gyapon to 0. Okay? So that's for bipolar return to 0. Masabtan na ba ang main nga difference between the unipolar and bipolar na return to 0 and non-return to 0? Is there any questions before I proceed? Sa NRZ or sa RZ? Somehow we could say that, no, Neil, sakto. Kay even sa logic 1 for return to 0, mag-register gyapon siya og 0 volts, no? Parehas kaniya, parehas sa BPRZ, no? Observe sa BPRZ. Even if 1 siya, di ba ang basta bipolar kay ang 1 ug 0, ang logic 1 ug 0 kay plus minus volts man, like plus volts o positive volts, negative volts, positive voltage, negative voltage. Pero even if positive voltage or logic 1, like here, mubalik din siya 0. So, yeah, I think that's correct. No? Na siya duha ka states for each logical bit. 0, logic 0, so mo low siya, balik yapon siya to 0 volts. Okay. So, next is, ang last one is BP-RZ-AMI. BP-RZ-AMI. So, what's the difference between this and yahang sama mag-improvement kibali ang BPRZ AMI sa BPRZ. So, sa difference na duha. Dili kayo na tumakuha ang definition. If you just consider the figure, no? So, let's try to find its actual na description be or the definition. The meaning day for AMI is alternate mark inversion. For AMI, for sure, basta logic 0, 0 volts. Diba? Atong given kay kuan man 1 1 0 0 1 0 1 0. Basta 0 gani, 0 volts siya. Pero ano mo-consider man siya nga bipolar? If, di ba, ang bipolar, we established earlier, na kung bipolar, ang logic 1 is a positive volts, ang logic 0 is negative 5 volts. No? So, kibali, yan na, plus minus voltage level. So, why is BP-RZ-AMI considered bipolar kung yung logic 0 is 0? Asaday itong plus minus volts. Diba? Kung ang previous na logic 1 is positive volts, the next logic 1 is negative volts, and vice versa. So this makes it still a bipolar return to 0. Then vice versa. Notice, we have two successive ones. So ang first logic 1 is positive volts. Ang next nga 1 is negative volts. Ang next nga 1 here, positive gapon. Meaning, ang next na 1, negative. No? So, if 1 ang sunod dire, example lang, if 1 ang sunod diha, we'd expect na ana iyahang waveform. Okay? So, sa mga successive nga ones, change niya ang voltage level from positive to negative or negative to positive. So, nakuha na ba ang meaning sa AMI, alternate mark inversion? So ga-flip ang one nga state. So ga-flip siya, sakto. With AMI transmission, successive logic 1s are inverted in polarity from the previous logic 1. So this table here summarizes the characteristic for each line encoding technique. Notice, lang sa average DC voltage. Notice that the average DC voltage for bipolar is 0, whereas for unipolar it's at some value, no? So again, nganong 0 siya because ang the one and the other na mga logic levels ng 1 and 0 are inverse voltages of each other. That's why kung ato lang ipangitaon average DC level, mag-cancel out sila duha. Okay? So any of these three, basta bipolar, mas better siya nga choice if ato i-consider ang average DC voltage. But for the minimum bandwidth, what does this mean? No, the minimum bandwidth that will be fed, no, to the system. How will it be computed? Here, the alam ng choices actually is either the bit rate or the bit rate divided by 2. So based sa table, as long as it's bit rate divided by 2, it's a better choice, no? Kaya mas gamay, no? Mas gamay siya nga minimum bandwidth. Kung mas gamay, mas better man, no? Meaning mas wide pa itong pwede magamit. So ano man na kabantay ta nga ang mga non-return to 0 is na divided by 2, ug ang mga return to 0 is wala. Okay? So minimum bandwidth is measured in the worst case scenario for na bit stream, no, na given input. So for non-return to 0 is a transition from either 1 to 0 or 0 to 1. So nadire ang diha mo ang basis sa minimum bandwidth. So this here is where the highest fundamental frequency occurs, no, sa transition between 1 to 0 or 0 to 1. So whatever is the bit rate, that's why itong divide into 2. No? Divide nato into 2 ang bit rate because the highest fundamental frequency could be measured between the transition of 2 logic levels na dili the same. Whereas for return to zero, there is always transition. There is always transition here. Again, ang transition sa non-return to zero occurs, transition from high to low or low to high sa non-return to zero occurs when the previous bit is different from the next bit. Okay? That's why i-divide na to into 2 ang bit rate para makuha na to ang rate sa transition. Whereas here, we do not need to wait for a transition from 1 to 0 or 0 to 1. Okay? Kaya every bit ka transition man siya. Diba? Mga na-point out earlier. So, whether 1, kung 0, wala, of course, no? Kay BP, RZ man din or UPRZ, I mean. So, for each bit, nagi transition may tabo. Kani logic 1, mag-high siya, then mag-low. Another logic 1, mag-high, and mag-low. So, bisan pag walay transition from 1 to 0, pero in itself, na transition nga kay tabo. That's why the minimum bandwidth for any return to 0 line encoding scheme is always the bit rate. The bandwidth is equal to the bit rate. Except for BPRZ AMI. For BPRZ AMI, the bit rate is equal to, the minimum bandwidth is equal to bit rate divided by 2. So, the same siya sa mga non-return to 0. Diba? So, the worst case scenario occurs during transition from a 1 to a 1. No? From a successive 1. Kanda. So, in terms of minimum bandwidth, mas better nga choice ang mga non-return to 0. But in terms of average voltage, mas better na choice ang mga bipolar. For both instances, pinaka-advantageous ang BPRZ AMI. So, ang naka-asterisk din mo ng mga denotes best performance or quality. So, in both cases, if we consider the minimum bandwidth or the average DC level, na-check ang AMI. Unlike lugar sa kaning upat nga conventional, tag sa ilang asterisk. Naman day gapon ang kuno, BPN, RZ. Better man day gapon siya nga choice. So, So, maning mga mga contenders kibali. BPNRZ o BPRZ-MI. So, dili lang man minimum bandwidth o average DC voltage atong i-consider, but also the clock recovery. So, there's no clock recovery mechanism for non-return to 0 because it's possible nga walay pattern, no? It's possible nga walay pattern nga kaka-emerge for non-return to 0. Whereas for return to 0, because there is always inversion for every transmitted bit, na clocking mechanism nga gaka-occur. And ang best nga clock recovery na scheme is ang BPRZ, BP return to 0. Observe mas yun nato kung i-compare nato tanan, no? Mas definite ang BPRZ in terms of clocking, in terms of pattern, so tungod kay namo gi-transition inside every bit compared lugar to UPRZ nga kung logic 0 lang. So best choice if ang atong need is clock recovery. or synchronization. Best choice ang BPRZ. But last but not the least, I mean, is error detection. So all the other line encoding techniques have no way for error detection. If ever na-transmit nga, if ever nakatransmit og error, no, there's no way of telling sa receiver kung may error nga dabo. Except for BPRZ AMI. Okay? Because for BPRZ AMI, it's impossible na makatransmit og something like this. No? BPRZ AMI. It's impossible to transmit something that, kung ano yung period, ano, diba? Kung successive ones, ano dapat? Pero if mo transmit ka siya ani, so there's an error occurring in this situation. May error. Ilahi man ang voltage level sa current nga 1 compared sa yung previous nga 1. So, makadetect ka ng receiver ani, then BPRZ AMI yung ginagamit. Kablugid siya na error nga itabo. At least, na a way of determining error. Compared lugar sa conventional na unipolar or bipolar na RZ or NRZ, wala gyud, no? At least ang AMI na. Also, mga consideration, bandwidth, clock, error detection. Yeah. So, kana. So, those are the considerations. So, for you, which is the best choice to use among the 5? Siguro ito na pinakadagan na asterisk, no? Which is ang kanang na AMI, BPRC AMI. Yes, well, in fact, mo nang among sa 5, mo na yung mas common na ginagamit, no? BPRC AMI. Dito lang siya sa clock recovery na sangit. Pero dili man pud poor yung clock recovery. Good man gani gihapon. Dili lang best compared sa BPRZ. Pero 3 out of 4 is better, no? Than 2 out of 4 sa rest. So BPRZ AMI is again the best choice. So napag yung mga improvements on top of these line encoding techniques that we call the digital biphase or Manchester code for BPRZ. For BPRZ, sa day noon yun eh. So digital biphase is a popular type of line encoding that produces a strong timing component for clock recovery and does not cause DC wandering. Wala na ako na-introduce ng DC wandering, no? Long story short, DC wandering happens kung na ay successive 0, then wala akong pwede, diba? Note lang na ako dire ano na ay such thing as digital biphase to counter for clock recovery, for better, of course, clock recovery. And to counter or to address DC wandering. So what is DC wandering? It's the proper term, lowering down of voltage level, degradation grid of voltage level. This is a normal phenomenon. Considering longer lengths or span sa mga telephone lines, degradation of voltage level. So, posible, no? An example of this might be sa receiver, ang positive 5 volts, tungkol kay taas kayong linya, because ang linya naman na siya resistance, makompound na siya the longer it gets. Ang 5 volts sa transmitter would now become only, let's say for example, 3 volts na lang sa receiver. No? And this happens especially if na successive na zeros, no? Or even successive na ones. Okay, kung successive na mga logic levels, even successive nga 1 na, dili mo na ang voltage. It will lag down. No? Because again, ang atong line is mukaon og voltage. So, ang positive 5 sa transmitter, 3 volts na lang sa receiver. And again, one way to mitigate that is to use biphase. So, tanaw taning first nga image or visual. For logic 1, still the same. No? Still the same ang logic 1 for BPRZ. Diba? 1. But for logic 0, okay, instead nga ana, supposed to be ana kung normal BPRZ, but if naman ka na ito biphase, dili lang na ay inversion sa voltage level, na po inversion sa phase. Diba? From 0 to 180. Kibali, ang logic 1, is yan na. Before, kung normal nga BPRZ, logic 0 is ano ba gyapon to? Dili. Ang normal nga logic 1 for ang normal nga logic 0 for BPRZ. Yan na ba di ay yan na. Kung 0 na po ng sunod, yan na. Pero for biphase, nani. So we're not going to discuss this one by one. Kaya naman po ang description din eh. No? Summary of biphase, mailer, and dicode encoding formats. Na yung mga each description. So of how each is going to work. No? So example lang, first, biphase M, no? Biphase mark. For logic 1, transition is in the middle of the clock interval, and if 0, logic 0, no transition in the middle of the clock interval. Note there's always a transition at the beginning of the clock interval. So, based on nga mga description, makuha naman na to how each works. No? So, kanang biphase M lang ta. Okay? Biphase M. So, this assumes na ay previous na state. Okay? May memory. Note, kanina sa taha, di lang tawag focus biphase M. Kumakuha na to ni. If ma-understand na to ang first, ma-understand na to ang tanan. So there is always a transition at the beginning of the clock interval. So if ang previous state is 1, no? Whether 1 pa ang first bit or 0, mag-change state gina siya. Mag-change state. Pero kung 1, transition is in the middle of the clock interval. Ano? If 0, no transition. Yan lang. Okay? Pag biphase level nga Manchester, ako lang na-ikuan. No? Last na. Example, this one. No? So, dili siguro mag-matter sa previous state. Basta for 1, i-transition from high to low in the middle of the clock. And 0 is transition from low to high. I think biphase L ni. Kaning atong primary nga example. No? Biphase L ni siya. Because transition from high to low in the middle of the clock interval, kung logic 1, but kung logic 0, transition from low to high. The same 0. Pag logic 0, from low to high. So if nalang na siya mga description, it's not easy for us to follow the digital biphase na schemes. Okay. So the practice daw ta. So draw the timing diagram for UPRZ, PPRZ, UPNRZ, BPNRZ, BPRZ AMI. Given the first 3 letters of your name converted to BCD. So each letter convert to BCD, each BCD code upat na ka bits. So 4 bits times 3 letters is 12. So we have 12 bits given. So convert your name to BCD. At least convert your the 3 letters of your name, first 3 letters of your name to BCD. So maka-come up mo ani og 12 bits na output. And those 12 streams of ones and zeros, draw the UPRZ, BPRZ, UPNRZ, BPNRZ, o BPRZ-MI ng mga timing diagram. Sige daw. Sabtan ang kuan, ang instruction para akong ma-transfer sa ikas nga slide ang kuan screen. So, kung type sa chat. Diba? So, anong 12 bits ninyo nga BCD code for your name, money kani sila, manang given. Okay. Ay, pila ba ka kuha ng BCD? Pila ba ka bits? Lapas 12, no? Ang isa ka letter kay change na sila ako ang kuan. ASCII man dito, no? ASCII, then ASCII to BCD. Ang ASCII ay duha ka digit nga hex. Then ang hex to BCD, 16 ito nun? 16. Hex to BCD. First two letters na lang. Para 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Para 16. 2 letters lang di ay. Okay, kung 3 letters, 24 tanan. Kaduno po mo ano, ang letter sa inyong name, convert to ASCII, then from ASCII, makakuha tag hex, hex to BCD. Example ako, DA. D is 44 hex. Og 41. So, 44. Kumani, 0000, 0001, 00, 010, 0111, 0101. Ito ba ni? 0100. Ang 1 is 0001. So, muna kong given. Kung BPRZ AMI, kung 00, ano? Zero. One, 000, 1. Hindi. 1, 000, 1, 0, 1. Yan naman siguro. No? Yan di kong BPRZ AMI. mataas lang siya, then di makabuok. Pero understandable lang magka. Sabtan la? May questions? Sabtan la? Okay.